So let us discuss ionization energy as a property of an atom. But that still we can call it one of the atomic properties or periodicity. Don't forget I still remain Tutor Prince Obajo Daniel Dinicole, also known as the Mathematical Arithophysical Biologist. So ionization energy is the energy required to remove a valence electron from an atom of an element to form an ion. So our bone of contention is the electron found in the valence shell. Yes, the energy required to remove the valence electron from an atom of an element to form an ion is called ionization energy. But then, what happens to the ionization energy of atoms when we move down the group of the periodic table and also across the period from the left to right? It is an established fact that ionization energy of elements decreases down the group. Now, for us to understand why, let us consider some group 1 elements such as lithium, sodium, and potassium respectively. These are just samples. Now, looking at lithium has atomic number of 3, which actually indicates the number of protons present in lithium. And since lithium is neutral in this case, we also expect the number of electrons to be what? Equal to 3. Now, what is the electronic configuration with respect to shell diagram? That is 2, 1. Now, drawing the shell, we have 2 electrons in the first shell and 1 electron in the second shell. Now, looking at the second one, that is sodium. Sodium has atomic number of 11, which means we have 11 protons. And since sodium is neutral here, it is not carrying charges. On that note, sodium also has 11 electrons. So, considering the electronic configuration of sodium, which is 2, 8, 1, we are going to have the shell to be drawn this way. Are you following through? We have 8 here, and we have 1 at the last shell. Are you following through? Now, the last one, which is potassium. Potassium has 19 protons. And since potassium is neutral here, we expect the number of electrons to be equal to 19. On that note, distributing the electron in the shell, we are going to have 2, considering the shell diagram electronic configuration, which is 2, 8, 8, 1. As you can see it presented there. We have 8 here. Are you following through? The third shell, we have 8 as well. 8th. And the last shell, which is the fourth shell, we are going to have just 1. Now, remember I said ionization energy decreases down the group. Now, why do we say, or why do we agree that ionization energy decreases down the group? Now, remember that ionization energy is the energy required to remove the valence electron from an atom of an element to form an ion. Now, look at what happens here. As we move down the group, you would agree with me that we have more shells drawn. Now, since we have more shells drawn, the electrons tend to move further from the center where we have the nucleus that contains the protons. As a result, the protons will not have much force of attraction for the electrons. Which means as you move down the group, the amount of energy that we need to remove the valence electron will be minimized, since the electrons are moving further away from the protons. Are you following that? I repeat, if you go down the group of a periodic table, we have increase in the number of shells. Here we have 2 shells, here we have 3 shells, here we have 4 shells. As a result, the electrons tend to move further away from the center of the of the atom where we have the protons. As a result, the protons have less nuclear charges or less nuclear force of attraction for electrons. As a result, when you move down the group, the ionization energy or the energy required to remove this valence electron is minimized. Hence, ionization energy decreases down the group. Are you following through? But then, what about across the period? Ionization energy increases across the period. Now, for you to understand why that is so, let us consider the elements we considered earlier. That is the elements in the period 3, sodium, magnesium, and aluminium. Aluminium, rather. So we have sodium, magnesium, and aluminium. These are period members of period 3 of the periodic table. So let's see what happens to them to actually ascertain why we said ionization energy increases across the period. Now, if you draw the shell diagram from sodium, we are going to have, are you following through? We are going to have 3 shells. If you draw for magnesium as well, we are going to have 3 shells, since they have the same period, or they belong to the same period, so to say. The last shell has 2 electrons. If you draw for the last element here, which is aluminium, in this case, we are going to have 3 shells as well. Are you following through? If you draw the last one, we have 3 electrons. Now, what is happening? Now, if you observe what is happening here, you notice that the number of shells drawn across the period is the same. For this period 3, as a case study, we have 3 shells all through. But then there is something that is happening here. If you look at the number of electrons we have here, for sodium we have 11 electrons, also 11 protons. Are you following through? For aluminium we have magnesium we have 12 electrons and 12 protons. For aluminium we have 13 electrons and 13 protons. Now, if you observe the trend of the number of protons here, you notice that it increases from left to right. As a result, since there is increase in the number of protons increase tend to drag the electrons closer to the nucleus. That is, as the protons increases from the left to the right of the periodic table, they tend to draw the electrons closer to the nucleus. As a result, the energy that will be required to remove these valence electrons will be higher from the left to the right across the periodic table. Are you following what I'm saying? This one, the number of protons here, the energy required, the force of attraction between the number of protons here and that of a number of electrons will be lower than that of this. This will be lower than that of this, which means that since this one here is higher than this, and this is higher than this, the energy required to remove the valence electrons we have there will be higher. Hence, we can agree that ionization energy increases across the period. Don't forget, I still remain your tutor, Prince Obajo Daniel D. Nicole, also known as the Mathaholic Arithophysical Biologist.